All right, everybody. So we're going to be taking a look at our translations now. So translating means the slides, like the up, down, left, right. So we want to think about what normally happens when we do our transformations in a graph. Excuse me. Have a tickle. And then we're going to talk about what that means when we look at our pictures, so what those effects are on the graph. So I'm going to have you take a quick peek at these. Pause the video for a second. I want you to think to yourself, what would each of these shifts do? Because they're going to affect our graphs for sine and cosine exactly the same way. So if your parent graph is x cubed, what would each of these do? All right, so let's see what you had. So for the top one, plus 3, that would be up 3. The next one would be right 3. Third one would be down 3. And then the bottom one would be left 3. So all of those things that you just did for x cubed, it'll have the exact same effect on our sine and cosine graph. So all of those transformations, translations, are identical where you put the numbers. Just in trig world, we have names for each of these. So we have what we call a phase shift and a vertical shift. So if you had to guess which one of these would be the up-down, probably the vertical, right? So a vertical shift shifts your graph up or down, depending on what the number is. It does exactly what you want it to, though. Plus goes up, minus goes down. Phase shift is the right or left shifting, so shifting back and forth, right or left. What you'll be looking for is seeing something inside of parentheses that will determine that you have a phase shift. So I'm going to write the general form now so we can see all of the values, all of the variables that we're going to have to be able to deal with, and I'll point out specifically then what the phase shift part of it is. And these equations can be written for sine or cosine. So I'll do one of each. I'll do phase shift and I'll show it with the sine function. I'll do vertical shift with the cosine function, but realize it works the same whether it's sine or cosine. So the function name can change and it works the same way. So every equation starts with an a value. That's your amplitude number. So we've talked about that already. I'm going to use sine. So we'll say the function name is sine. And then we have our k value. Our k value being telling us something about the period. How many complete graphs do we have in 2 pi? Then if there's going to be a phase shift, there'll be a parenthesis. And then we need our variable to stand for the angle. So you can use x's or you can use thetas. It really doesn't make any difference. So I'm going to go ahead and just call it an x, but theta would be the same thing. When we do our shifts, just like in our warm-ups, it would be x minus the shift. So x minus, and this looks a little goofy, I know. You'll see why in just a second. The shift is the c over k. Now they call it that for a really specific reason. We'll talk about that in just a sec. But the c over k, that is your phase shift. Whatever number is being added or subtracted to the angle on the inside is going to be the phase shift. Now, the reason they use c over k is because you could have, everything else is the same here, but look at the green version, distributed the k through. So it'd be k times x minus k times c over k. The k's would divide out, and you would be left with just a c. So you could have just a c and just a k. It might be a little bit easier to write that way for some people, and in your graphing calculator, when you type in a sine or a cosine, it automatically gives you this first parenthesis. So this bottom one, the green version, might be a little bit easier to be able to type that in as well. But technically, the actual phase shift is when the k value is factored out, when the x coefficient on the inside is just the 1. So you need to make sure when you're looking for phase shift that it's always x minus the shift, so you know exactly what that shift value is going to be. So we will practice that and talk about it, but I know it looks a little goofy when you write it, but that's to accommodate that distributing out. Okay, the up or down does exactly what you want it to do. So for this one, I'm going to go ahead and write it with a cosine function. You would still have amplitude. It could be sine or cosine. I'm just choosing to use cosine. We're still going to have the k, and maybe you have an x minus c over k. Maybe you have a phase shift, but the part that's new now is at the end, or it could be at the beginning. They could do h plus and then the value of the function is our up, down, our vertical shift. So this plus h, that's your vertical shift. Now, if it's going to go up, that's going to be a positive. If it's going to go down, it would be a negative. It's exactly how you want it to be, what we talked about for any other parent graph. And again, the other version of this would be if you multiply through but that doesn't affect that vertical shift at all either. So it's just two different ways of writing the same thing, whether it's distributed through or not. So what we're going to do today in this day one is just demonstrate each of these kind of separately. So I'll do an example with a phase shift, an example with a vertical shift, and then what we'll do is we'll take a look at what happens when we start kind of putting everything together than that we did before. So if we're changing the amplitude and the period, and it's reflected, and phase shift and vertical shift, we'll work our way all the way through all those different possibilities. And write equations, because again, the real life modeling for this is what's going to be important. Okay, so let's take a look at our first one. We'll list everything we know. Our amplitude, remember the number coefficient out front, that would be a 1, so there's no vertical shifting, compressing I should say, or stretching. Period is 2 pi divided by k. Well, k in this case is a 1, so 2 pi divided by 1 would be 2 pi. In other words, there's no change in the horizontal. There's no stretch or compress. Is there a phase shift? Look for that visual cue. I'm seeing parentheses. That means there's going to be a phase shift. If you look inside, the coefficient is a 1, which is fantastic. So it's x minus this number right here would be that shift, that phase shift. Now that means we're going pi units, and it's going to the right because it's a positive in there. It's x minus the shift. Now, some people say pi to the right, but if you just say positive pi, that should assume to you that that means you're going to the right. If this had been x plus pi, then that means it's x minus a negative pi. That would have been a phase shift of negative pi, or pi to the left. So just depending on how you want to say that. So pay very close attention to the sign in between. It's just like what we've always done, but that's which way we'd be going. Now, if you don't like that, if that's kind of harder for you to figure out, or you don't want to look at it that way, the other way to do this is just take what's ever inside and set it equal to 0 to solve for the phase shift. Because what a phase shift means is how far your graph has been shifted from 0. So if we want to see how far our x value or angle that we moved from 0, we just need to see what makes that 0. So you can solve for the angle that's your phase shift as well. And you can always do that. So if that's an easier way for you to think of it, that's great. All right, for this one, there is no vertical shift. There's nothing being added or subtracted. So I usually just say 0. Some people say none, whatever makes sense to you. And is it reflected? Well, no, because there's no negative out in front with that 1 amplitude value. So it's not reflected. Okay, so here's my process for this. I'm going to go ahead and do my 4 tick marks here. I'm going to graph the original unshifted version first. So I'm going to set up my scale for the appropriate period. So I'll put my scale in here and the appropriate amplitude. So it's 1 and -1. This is a good strategy for people that kind of like to do things in multiple steps. There will be people who can go automatically, especially after a little practice, right to the shifted version of the graph, and that's fantastic, but you don't have to. You can always do it in multiple phases. I would recommend using maybe colored pencils, or lighter and darker, or dash and solid, or something that you know which one is your final version versus maybe some of your just practice versions to get to the final answer. So just make sure you know what that is. I'm going to do my original unshifted in green, just so you know what I'm using here. So this is a sine function, so it starts at its middle, then goes to its max, its middle, min, and then back to middle. So this green graph right here is my unshifted version. This is y equals just sine of x. I haven't shifted anything yet. Okay, so now I'm going to do my shift. I need to go pi to the right. So I have to take a look and see how many intervals, how many tick marks on my scale am I going to need to add on here to be able to shift it over. So I'm going to need to add some space. So pi is 2 intervals over from 0. My interval that I'm going up by, my 1 interval, is pi over 2. So pi, I would need 2 more intervals to move this graph over, pi to the right. Well, if I move the graph over, I better have labels on that then too. So I need to figure out what these next 2 tick marks are. So let's see if we can figure out what the first one would be. If your interval is pi over 2, this is the 5th tick mark, so there would be 5 of the pi over 2's. So that's one way to think of it, just like we did that 3rd interval before. So take whatever your first interval is. This is the 5th tick mark. It would be 5 of those then, 5 pi over 2. Or you can just count up. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. That works. Some people just add pi over 2 to the 2 pi. So add it on, you get 5 pi over 2. However is easiest for you to think of. Now we need to go one more. So if this is 5 pi over 2, the next one would be 6 pi over 2. But 6 pi over 2 reduces down to 3 pi. Some people just look at the pattern too. Every other tick mark is a whole number. So 1 pi, 2 more tick marks, 2 pi, 2 more tick marks, 3 pi. Whatever is easiest for you. Okay, so I'm going to graph my final shifted one in red. So I'm going to use red now for my final graph. Every single point on this original graph is going to get picked up and slid over 2 tick marks or pi radians to the right. So this normal original point that was at 0, 0 is now going to go 2 tick marks over or 2 intervals over or pi units to the right. Now I just slid it over. That's what a translation does, a phase shift. Now some people then just go follow the pattern. So where does it go after the middle? It would go up to its maximum. So you can just follow the pattern. Or you can think of it as I'm taking this next point that was at pi over 2, 1 and moving it over 2 intervals or pi units to the right as well. However you think of it, it's going to have the same effect. So the graph is congruent. It's exactly the same size and shape. You're just sliding it over. And then after the max, it goes to the middle, then to the min, and then back to the middle. So this red graph is my final shifted version. I would say probably 90% of people would graph it that way, and that's great, and we have our final shift, and it's beautiful. But what some people notice, they don't really want to have to add the tick marks and try to figure out the labels because that's kind of clunky and it takes a little bit of thinking. So they do this a little bit differently. They think about what this graph would look like if they just worked backwards. So if they slide this first point over, where would it be going prior to pi? Well, if it's at the middle, it would be down to the min and then back to the middle. So they would think of one complete cycle, I'll do it in blue here, as being this. It's the same graph, it's just showing starting at 0 because some people really like to think I'm always going to start at 0. What would this cycle look like if I do that? So showing one complete cycle before it repeats itself, you could do the blue one, or you could do the red one. That would be fine. There's really infinitely many ways you could show this. It just depends on what's easiest for you to think of. Now, what's kind of cool about it, that blue version kind of helps you see that really translating this pi units to the right is actually the same thing as just reflecting it, right? If you look at the green original one and the blue one, those are just reflections. So there's a lot of different, what we could call equivalent transformations to graphs where we do things to the graph and they end up giving you the same points, which is kind of cool. So you can really think about it in either way. So if it's easier to just slide it over, great. If you want to always start at 0, you can do that too. Those are all going to give you equivalent graphs and points. Just make sure you show enough to show one complete cycle. Okay, let's try the other shift that we talked about today. So let's list through what we know. So amplitude is 1. So that's our A value out front. Period is 2 pi. That's because our K value is also 1. Is there a phase shift this time? No, there's not because there's no parentheses. So this graph has not been shifted left or right. So I just say 0. You could also say none. That's fine too. Is there a vertical shift? For sure, because we have something at the end. So that's your vertical shift. And that means this one is going down 2. So if you say -2, I'm going to assume that you mean your graph is going down 2. Is it reflected? Nope. We'll do some tomorrow that are reflected. So for today, we're just going to focus on the other shifts. There's no negative out front there, so there's not a reflection. So I'm going to go ahead and set up my amplitude and period on my X and Y axis, and then again I'll do the shift afterwards. So I'm going to kind of do it in 2 steps. You can definitely though do this all at once, and especially as you get better with it, you'll be able to do that. Okay, so period is 2 pi. So we have our normal scale on the x-axis here, our regular period, and our amplitude is 1. Now we just have to be careful, especially when we start having vertical shifts. Really important that you go by a regular interval on the vertical scale, and I like to go by ones unless I have a really big graph and it makes sense to go by something else. So just think ahead when you have these vertical shifts and make sure we have enough room to do what we need to do. Okay, so cosine, I'm going to do my first graph in green, so this is not the shifted one. Cosine starts at a max, middle, min, middle, max, cosine. Smooth continuous curve. This is unshifted, so y equals cosine of x. So again, if you have multiple colors and you want to be able to show this, that's a little bit easier maybe to do that. Okay, what does a vertical shift mean? It means you're going to take all of those green points and you're going to slide them down 2 units. So you're picking them all up and you're sliding them down. So think of like that graph is connected to a horizontal line, and you're picking up that whole thing and you're sliding that horizontal line down with the points attached to it. So where's our middle of the graph currently? On the parent graph, the middle of the graph is always the x-axis. So this x-axis is the middle. So that middle now is going to move down 2 units. So if you move 0 down 2 units, 1, 2, I'm going to be down at -2. So the new middle of my graph is going to be down here at -2. This is called the midline of your graph. So it's called the midline. The equation of it would be y equals -2. It's always y equals because it's horizontal and whatever the shift is. So it's down 2, so y equals -2. That would be your new middle. So what we have to do to get our final graph then, and I'm going to do my final graph in red, is literally slide all of those points down 2 units. So like the whole graph is getting shifted down. You have to preserve the size and shape of it, but it's sliding down 2. So if my maximum was occurring at 1, if I move that down 2 units, my maximum value on this graph will now be occurring at -1. I'm sliding it down 2 units. Okay, so let's talk strategy here. Some people then, if they know where the max is, they just go ahead and draw the pattern. So after the maximum, where does cosine go? Well, it goes to the middle. Well, where's the new middle now? It's at -2. Then where does it go? Minimum. Oh dear, we need to add some things on our scale here. I need to be able to go down to our minimum point, which would be 1 unit below. We preserve that amplitude, so that would be down at -3. Now think about if that makes sense. Each of these points then are moving down 1, 2, and this point 1, 2. So I'm doing exactly that same slide down 2. So after the min, back to the middle, and back to the max. So this red graph would be my final shifted graph. And again, I know some of you will be able to just go right to that. That's fabulous. Now, let's talk about amplitude. Distance from the middle to the top and the middle to the bottom in this graph is still 1. Super important. It was 1 here. It still has to be 1 on your shifted graph. Congruent shape, same size and shape. So we just shifted down 2. So that's a vertical shift. All right, so we're going to do just one more graph here in this day 1, and then we'll write an equation. I just want to make sure that we have enough to be able to see what's happening and feel pretty confident about what we're doing on our picture. So I want to do one like this. I want to do one more of the horizontal shifting that has a little bit different look for how they write it. So let's see if we can figure out what this looks like. All right, so we have our amplitude of 2, and that's coming from the 2 out front. Period is 2 pi divided by k. K is 2, so that means our period would be pi. So what happened to our graph? Well, so far it's been stretched vertically, that's the amplitude of 2, and it's been compressed horizontally. It's only pi. So my k value, this is k, is the 2. That means I can have 2 complete graphs in 2 pi. That means it's compressed. Is there a phase shift? Well, I see parentheses, so yes, there's going to be a phase shift. This is one, though, where that k value is on the inside, so you really need to factor it out. Theta is the same as x, and see what that phase shift is. So we've got to pull that 2 out so we can see how far theta has moved. So if you're okay thinking factoring, then pull that 2 out. So 2 times what will give you pi? 2 times what value in here would give you pi? Well, that would have to be pi over 2, right? Because if you do 2 times pi over 2, the 2's would cancel. So the phase shift is going to be pi over 2 to the right. It's a plus, or it's a minus in there. So it's a positive shift. We're going to the right. Now, if that's hard for you to see, and especially with fractions, it can be kind of tricky. Remember, you don't have to do it that way. You can take whatever on the inside and set it equal to 0 and just solve for theta to see what that shift is from 0. How far did they move from 0? Well, it's pi over 2. So if that's an easier way for you to think of it, just set it equal to 0 and solve. What is that shift from 0? Okay, does this one have a vertical shift? Nope, there's nothing added or subtracted. Not reflected again because there's no negative out front of that 2 sign. So I know that there's no reflection. So I'm going to go ahead and do this in 2 steps again. So I'm going to put my final period value as my 4th interval, my 4th tick mark there, and then I'll do the shift. Again, I know some of you can do it all at once. So halfway would be pi over 2. Half of that would be pi over 4. So then the 3rd interval would be 3 of those, 3 pi over 4. 3/4 of the way to pi. Okay, I'm going to go by ones. I know for this one there's not a vertical shift, but I really want to get in the habit of showing going up by ones so I'm not messing anything up as far as vertical shifts if I do have them. So I know some people would just put 2 and -2 and call it good. You'd be fine in this one, but just kind of be thinking ahead for if we have more than one. Okay, so sine graphs. Again, this is not my final. I'll do my kind of pre-one in green here. Starts at the middle, max, middle, min, middle. So it's been stretched vertically, compressed horizontally. So we have our initial graph. Now we're going to move this pi to the right. So if I go pi to the right, that would be, or sorry, pardon me, pi over 2, looking at the wrong line. The phase shift is pi over 2. If I'm going to go pi over 2 to the right, I'm going to need to add some intervals again. And pi over 2, once again, is 2 intervals down. So I would be moving over 2 more intervals if I'm going to slide this graph over. So what would our next tick mark be labeled? Well, that would be 5 pi over 4 because it's the 5th interval of pi over 4. If one tick mark is worth 1 pi over 4, then this is the 5th one. 5th interval would be 5 of them, or 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Then the next one would be 6 pi over 4. That reduces down to 3 pi over 2. So if you're going to slide it over, we need to make sure we have those labeled. Okay, so I'm going to do my new graph in red. I'm going to take everything and slide it over 2 intervals, or pi over 2 to the right. So what was 0, 0 would be pi over 2. What was pi over 4, 2 is now going to be at 3 pi over 4. So it goes from the middle to the max, and then to the middle, to the min, and then to the middle. So this red graph, I would say, is what most people would probably show to show one complete period. But remember, this graph continues infinitely in both directions. So what other people might think of is taking the graph that was before the x-axis or before the y-axis and sliding it over. In other words, continue the pattern back. So if you were at the middle, it would go to the min and then back to the middle. And they might show me this blue graph, and that would be exactly the same thing. You can show any part of it. This graph continues infinitely, so whatever chunk of it makes sense for you to show. So the red one or the blue one, either of those would be fine. All right, let's take a look at writing an equation next. So the last one I'm going to do with you is write an equation, just so we can practice what that looks like, so we have sort of the basic points down. Then tomorrow we'll do lots more. This day 2 video, we'll do lots more with the graphs. All right, so in general, we still always have to deal with an amplitude. They want us to graph a sine function, so sine. I'm going to have something about period, something about a phase shift, and then something about a vertical shift. Now, any of those could be 0, I guess, except for amplitude, but this would be the general form with everything. So A is amplitude. We know that one. The k value tells us something about period. Period is 2 pi over k. That's the only one you have to solve for. C over k is the phase shift. Notice the just regular k value is factored out front here. So x minus c over k, the c over k gives you the phase shift. Then how far did you move left or right? And then the h, that's your vertical shift. So as we're substituting values in, most of these we can just plug in the right spot, but we have to think about only the k. That's the only one we have to actually solve for. All right, so y equals, amplitude is a half. So technically, plus or minus, because even a negative half would still have an amplitude of a half. It means how far is the max or min from the middle, so it's going to be plus or minus. Sine, because it's a sine graph, let's figure out our k value. The period is 4 pi, so think about that. Normally, it takes 2 pi to go through a complete graph. Now it's 4 pi. That's twice as long. So that means how much of the graph would you see if you only graph 2 pi? How much of the graph is in 2 pi? Well, if it takes 4 pi to do the whole thing, you're only going to see half. So k is going to be a half. So if you can figure that out, if that number is nice, fantastic. If it's not, we've got a formula for that. We know our formula is 2 pi divided by k. They told me the period was 4 pi, so I can put that in and solve for k. So multiply both sides by k, divide by 4 pi, and we get k equals 1/2. So it's totally fine to solve for it. They might not all be nice numbers either, so you might have to use the formula. But if you can figure it out because you know what's happening to the graph, fantastic. Okay, so k is a half. Now, do you need parentheses? If you have a phase shift, you need parentheses. So the next thing I'm going to have is parentheses because I have to separate out what that shift is, left or right. So I'm going to use x. You could use theta if you want. The phase shift is pi, positive pi. That means it's going to the right, which means we need minus pi. If this phase shift was negative pi, that means it would be minus a negative pi, and it would end up being plus positive. So that's the only difference. Huh? Get it? Difference? It's a minus sign. Yay! Bad joke. All right, so if it's a negative, just be careful. But this one was a positive, so that means it's just regular old pi to the right, so it would be minus. But if it was a negative shift, minus a negative, it would be a plus sign in between there. So be cautious on your sign. And then finally, the vertical shift. So vertical shift, it says, is -2. That means my height, it went down 2. So really the only one you ever have to solve for is just that k value. Everything else is just putting it in the right location. Now let me show you this and see if you can tell what I changed, and is this also okay for your equation? So see if you can tell what I did. So I distributed through the half. So a lot of people, if they're going to type this on your graphing calculator, because they give you that first parenthesis automatically, they would like to type it in this way because it's a little bit faster. That's having the K and the C value in there. So it's kind of just the multiplied out version. I prefer the red one for graphing because I know exactly what the phase shift is then. But the green one's fine. It just means you've distributed through. It might be a little bit easier to type. So both of those would be totally equivalent equations of this model. All right, so that's kind of our first part to this. We'll do some more examples in the day 2, so you can get a little bit more practice putting everything together. We really separated and didn't do many of them at the same time. Tomorrow we'll work our way up through all the different shifts, everything together, all those different transformations.